Welcome to Tech Drill. Today, we are diving into something truly exciting: GitHub Copilot Vision Support for IntelliJ. Imagine this: you show a diagram and your IDE writes the code for you. Sounds like a magic? No, it is Copilot Vision and it is real, it is powerful, and it's changing how we develop software. Today, we will be discussing about why this vision is very important, why image processing matters in software development, and the new addition of vision capability for IntelliJ, and a couple of demos addressing various diagram processing across our SDLC. And this hand-picked 9 demos are a subset of image processing in our SDLC. We process a lot of images. So today we will see how we can process 9 different diagrams in our SDLC cycle with the help of GitHub Copilot Vision Support in IntelliJ. Starting with the developer challenge, without vision support, software development is difficult. We all went through this manual interpretation of architectures and design diagrams. We get a set of diagrams from architects or designers and spend hours to translate them into boilerplate codes or even understanding the insights of them. As a developer, understanding an architecture diagram which captures the functional, non-functional features is one of the complex tasks in our development cycle. Most of the time, we avoid understanding the non-functional details, focus on the development aspect or the functional areas, which leads to future security issues or the reliability issues, performance issues, or NFRs are not addressed in the beginning. There is a lot of risk in the human errors, missing the details, misinterpretation of the diagram altogether, as the architecture diagram or design diagram talks in terms of architects and designers. It may not be aligned to a developer technology or developer language. This leads to missing details, lot of wasted time. We may reach to some of them to understand what exactly this diagram, and it's all depends on the availability of the architects or designers. Normally in a project, 100 developers with 1 architect or 2 designers, and they need to spend time to explain the architecture and designers. Most of the times they speak a different language than the developers, and it's obviously impact overall user experience and transition issues. We have all been there. Visuals and code often live in different worlds. But if we could bridge this gap, why image processing matters in software development? This is where image processing enters the scene. By turning diagrams into insights or codes, we are not just saving time. We are boosting the accuracy, enabling collaboration, and embracing agile iteration like never before. Here, different image process technologies allow us to talk in the same language as designers. Now the designers, architects, and developers can speak same language visually. A common visual language reduces the miscommunication and leads to better understanding of the visuals. An effective image processing not only gives the code, it explains the diagram, what exactly the diagram captured, what kind of insights it's having. It can be functional or non-functional. Consider the diagrams we normally use in an SDLC. We start from an architecture diagram, but our HLD, LLD may have low-level designs like the use case diagrams, class diagrams, sequence diagram explain the sequence of operations, or a flowchart explain a complex feature implementation. All these diagrams play a major role in our end-to-end development process. When your tooling understands the diagrams, development becomes faster. Here comes GitHub Copilot Vision support in IntelliJ. Vision capabilities are already available as part of VS Code and .com chat. Now, this capability is integrated into IntelliJ IDE. With Vision capabilities, from the IDE, you can look at the diagram, get the insights, translate that into meaningful code as well. This will enhance your productivity, and whether it's an architecture diagram or a class diagram or even a hand-drawn notes, Copilot Vision interprets it and helps you to build real code from it. Let us explore this work through real hands-on demos. We will start from architecture diagrams. If you consider the different diagrams in the SDLC cycle, architecture diagrams and the last network or deployment diagram is the most complex diagrams which the developers normally try to ignore it or not able to understand properly. So we'll start with an architecture diagram, how Copilot will be able to understand the diagram, get an insight, explain properly to us. Let us start with our first use case in IntelliJ. We can either drag and drop the images into the chatbot, or you can attach it as a reference to your prompt. Let us start with an SOA architecture. I am going to drag and drop the architecture and asking Copilot to explain this architecture. Here we passed a very simple SOA architecture, and Copilot is going to explain every parts or components of this architecture in detail. Looks like service consumers are easy to understand. These are the client application that consumes the services. When it comes to service bus, it looks little different for me as a developer. Let us take service bus concept and ask Copilot to explain service bus concept in detail with examples. This will clear the concept for a developer. It gives a granular information in detail what exactly a particular component in your architecture diagram. If the overall explanation is not giving that clarity, you can drill down to each component, each interactions and understand further. Here, service bus concept is explained, and also the key features of service bus is explained, and it's provided some use cases in terms of order service, inventory service, how this bus communication is there in a e-commerce platform, and also it's given an implementation in Java considering Apache Camel to implement a service bus. That's a normal implementation aspect, and the configuration is given in detail with an explanation what exactly this is doing. So the Copilot Vision capability help us to understand a complex architecture diagram even at a high level, or get an insight or details with examples for each of the component implementations. If you don't want it in Java or a particular technology, you can prompt and ask Copilot to give the examples in a target language or technology stack. This is our first vision processing, getting an insight out of the architecture diagram. Now let us quickly move to the second example where we normally deal with a lot of class diagrams. That is part of our high level design or low level design. We define the complex class diagrams and the relationship between different classes. How we can create the class files out of these class diagrams. The UML class diagrams play a major role in the overall SDLC cycle. It's defined the granular class components which can be reused, or it's aligned to the OOPS concepts. So how we can use a class diagram and quickly create the class stubs, or the basic step or the structure of a Java class out of that. Obviously, the class diagrams will have minimum information, may not have a detailed implementation level details. So let us see how we can use a class diagram to get the details. This time, I am taking a class diagram into my chart and asking Copilot to generate Java class. It can contain multiple classes. For the class diagram, for the diagram is enough attached. So this time we are going to generate classes corresponding to this class diagram. This is our class diagram, which consists of an order class, a customer class, personal customer, and corporate customer order line. And there is a relationship also. So when you look at the implementation, it should adhere to the relationships as well. It started with the order class. This is the first class. It defined the complete one. And there is one-to-n relationship, means one order can have a list of order lines that is clearly captured as part of the implementation. Then it went to the custom order line class. That's a subset or the subclass for the, we can call it as a subclass. It's a included class for the order that is defined. Then comes to the customer class with a very high level information, and this as an abstract class, because this class is going to implement it into these two. This is an abstract class with minimum information, and that class is getting extended or implemented as part of corporate customer and personal customer. Customer class is extended or implemented into the subclasses. Here this the main class, and we have the subclasses concept is came in picture. So this class diagram, it's not only directly converting each of the class definitions, it's also handling the relationship defined as part of each of these lines. How you defined a relationship, that is captured properly as part of your entire class design. Moving from the class diagram, let us see how to generate an APIs and models from use case diagrams. So we have seen the architecture diagram, got the insights, class diagram converted to the steps in Java or the structural elements in Java. Now use case diagrams is mainly we define the roles or the actors, the humans in the system, and how they interact with each of the components in the system. So a code generation out of this provide two angles. One is it defined the actors, and also it's defined the basic structure of each of the methods in our use case. So that's why we are going to convert the use case diagram into an API layer. So again, removing the class diagram and adding a use case diagram this time. And asking Copilot to generate, as we are dealing with Java a lot, it should be Spring Boot API classes and Spring Boot API class for the diagram. And obviously, normally the use case diagram will have actors and the corresponding object processing. We have the concept of models coming there. Let us explain that as part of the prompt. Add models separately in different classes. We need each model in a different class files. Apart from the Bootstrap API or the controller class, we are looking at models classes as well. So this is our use case diagram. We have an online store application with two actors, visitor and admin. Admin have access to update the product, change order status. Visitor can place order, cancel and manage order. API controller, it is Spring Boot API with a proper routing on top. Place order, and there is a cancel order, manage order, change order status and update products. All this captured with the proper routing and the required information. Order ID is required for managing the order or cancelling the order, that is captured as part of the routing. Now coming to the order model, it's defined the basic structure of an order. It should contain an ID, customer name, status and list of items. An order item contain a list of item details in terms of product ID, quantity. If we have more details, we can add it there. And a product model with multiple details. So we have around 3 different models along with the API class generated out of this online store or this particular use case diagram. For a developer, this is the starting stage. He got the basic structure and what kind of APIs or the endpoints required. Now from here he can start building on top of this one. He can ask Copilot to complete the implementation of each of these methods. So let us move quickly into the next one, that is to data modeling. So we deal with architecture, use cases, class diagrams. Now obviously we all start with a schema or a data components. It's maybe defined in a SQL or NoSQL databases, which deals with some kind of entity relationships. Normally we model the database schema in an ER diagrams. It's defined the entities or the tables with the corresponding fields and the primary key, foreign key relationships. So let us see how quickly we can generate a schema out of an ER diagram which may present in your LLD or an HLD document. Going back to here, let me just close the existing diagrams and take the new ER diagram and asking Copilot to generate T-SQL create schema script for the ER diagram. So let it generate. Meantime, I'm going to add one file here for holding this data. So let me define it as schema.sql. It's a SQL file and here goes the details. So I'm just inserting the schema. So the one which we passed is entity relationship diagram with the product, supplier, order detail, shipment, orders and customers. And if you look at here, it having the table customers, suppliers, products, orders, all the tables are captured. Along with that, it's defined the primary key and also the foreign key relationship. Wherever it's needed a foreign key, it's defined the foreign keys as well. Primary key and foreign key is captured correctly. GitHub Copilot taken this entity diagram and converted that into a proper schema creation script. Now, if we are doing it manually, we may miss some of the foreign key relation, maybe a primary key relation, or typing all these field names may take its own time. If you have a custom instruction, Copilot takes that also consideration for generating the entire table schema. So we have the schema here. Let me just quickly modify some of the things for a later demo purpose. I just modified customers and the suppliers. Few fields are removed. That's a simple modification I have done. Later we'll look into this schema. Going back to our deck and to the next demo. How to generate the test cases from visual flows. If you are using a TDD approach, a test-driven development, we start with a test generation, derive the test scenarios, edge conditions, the boundary test cases, negative and positive test cases. That's the first element you generate. Then you generate the actual implementation of the functionality. If that's the approach, if you are following a TDD approach, how we can generate the test cases out of a flowchart. Here a simple flowchart is provided and asking Copilot to generate JUnit test case for the functionality explained in this diagram. So instead of implementing the functionality, we are going for creating the test cases first. Then based on the test case, we go ahead and implement the things. So here it came with the JUnit test cases. Even the implementation also it's done. But this the main thing, JUnit test cases for prime numbers. This is our flowchart. It's a little blurred kind of thing. It's not a clear picture. And Copilot is able to extract the functionality and come up with the proper test cases. If you are using a test-driven approach and you want to create the test cases out of any of the visual element, Copilot is able to help you there. Always the network topology diagrams are confusing. The target deployment diagrams or network diagrams, which is used for deploying your applications and the related components to a cloud provider or into an on-premise system. Earlier we use a manual deployment of each of the components, but nowadays we use a IaaC model, infrastructure as a code model, and deploy the code using the configuration scripts. So from the topology diagram, we may need to understand each of the elements in the diagram. Also, a configuration script out of the diagram. We have a simple AWS web application diagram here. This is the diagram where the user will have interaction with the Amplify, and that use a Amazon Cognito and AWS Lambda is capturing the main functionality in a serverless mode that talks to the GraphQL and DynamoDB. So it's a very simple AWS diagram. Either you can ask Copilot to explain this diagram or generate Terraform. I am using Terraform, or you can go with the CloudFormation or what's the technology you are using for making this infrastructure configuration. You can specify that. Generate Terraform script for the diagram. Simple prompt by passing the diagrams will brings you more insight and the code related to that particular one. Here Copilot is defining or suggesting the detailed Terraform script for provisioning this entire diagram. Once it's available, we can customize by giving the names or the other configuration elements. It's given an explanation also. It's identified around 5 different resource requirements and came up with this entire Terraform script. Quickly you can generate the Terraform scripts out of a deployment diagram or cloud architecture diagram. Copilot is there to help you streamline the complete provisioning of your target environment. The next one is screen design to front-end code. Designers pass the screens a design in an image format normally. It can use any of the technologies and coming up with a great screen design. The developers look at the screen and understand the colors used or the themes used and the placement of each of the element and come up with the code. GitHub Copilot with a vision support streamline this design to code conversion. It can directly create the code out of the design, and as a developer we can fine tune the code with our requirement. If you have a specific branding guidelines or any kind of usage elements, you will be able to pass that as part of the Copilot custom instructions. We are quickly generating a screen design. In our case, we have a website design and asking Copilot to generate HTML, CSS scripts for this design. And our web design looks this way. It's a symbol accommodation page with 3 cards and image and associated data points. It's coming up with the detailed CSS and HTML. This is the design we received and almost similar to our design we passed, except obviously the images needs to be added to make it exact match. So this is how quickly you can transfer a image or design, website design into code pieces. Now moving to another exciting area. Till now we deal with multiple kind of diagrams we use in the SDLC. Started with architecture diagram, class diagrams, flowchart, the ER diagram, use case diagram, etc. Now we are going to modify an existing code. It can be a code built on top of the design or based on any diagrams. Obviously, in our development journey, we go back and modify the schemas, modify the class structures, the sequence diagrams. Everything gets modified over the time. We can align the diagram modification with the code modification. So here we have the schema already added based on the previous one, and we modified some of the fields earlier, and we have a order ER diagram which is edited. If you look at this diagram, we have a new table added with relationship. We removed some of the fields from customers and suppliers table design. So let us take this diagram and see how we can modify the schema based on the modification in the diagram. Let us add both the ER diagram and the schema file. Both are added and asking Copilot to modify the schema code based on the updated ER diagram. Over the time, we modify the schema, modify the diagrams according to that. How we can align both the diagrams and the code. That is what we are doing. Here we added a new table altogether. You can see that this is the last table, shipment partner, which got added here. And also we removed some of the fields in customers. This table is completely aligned with all the fields defined in the diagram, but in the schema we don't have all fields here. We have till city, these 3 fields are missing. Copilot identified that, based on that updated the schema code. In case ER diagram removed some of the fields, then your updated code also remove that fields. So this feature, you can update the code based on updated component diagrams is very important. It's an exciting thing. Your architect or designer or the leads change something in the complete architecture or the schema files or the relationship between the classes, you can take the Copilot to modify that based on the updated diagrams. Coming to the another exciting feature, the diagrams no need to be fine-tuned or the created based on a computer system program or anything. you can use hand-drawn diagrams, a diagram out of your group discussion or sprint planning. Use that diagram. Copilot is able to read through these hand-drawn diagrams and get an insight out of this. So let us take our beautiful diagram on an Azure architecture, removing all other things. And here my beautiful diagram, hand-drawn diagram, and see how Copilot is able to identify the detail. Explain this diagram. So that's a simple prompt I have passed to Copilot to get an explanation of my hand-drawn diagram, and it's able to identify there is a user, firewall, a VNet with the two subnets. The first VNet contains a VM. The second one hosts a web application that talks to a storage account. And the web application is hosted in the subnet 2. Storage account is as part of the Azure and it's connected to subnet 2. Even the links, lines drawn, everything is considered as part of the interpretation. Copilot is able to interpret your hand-drawn diagrams and come up with a detailed explanation. And in case you want a Terraform script or Bicep scripts out of this, you will be able to get the help from Copilot to generate the script out of this diagram. Hope you are also excited like me about this hand-drawn diagrams and obviously the code modification based on a modified diagrams. So in a nutshell, this integration of GitHub Copilot Vision with IntelliJ increase our productivity, streamline lot of coding workflows for the developers. The developers can get an insight out of the diagrams, convert the diagrams into the corresponding code, modify the existing code based on a modified diagram, and also you can pass your hand-drawn diagrams out of your Spring meeting or any of the meetings. Copilot is able to help you there as well. That is the power of GitHub Copilot Vision in IntelliJ, transforming how we build software one diagram at a time, from architecture to API, from hand-drawn sketches to fully functional code. Copilot is bridging the gap between designers, architects, developers, and the testers. If this blew your mind, if you like it, don't forget to like, share, and subscribe to Tech Realm for more insights on GitHub Copilot. Until next time, keep building smarter.